Okay, today we're going to be using slopes to compare unit rates. It says you can compare proportional relationships presented in different ways. They may give you a table or a graph, but from those you can get the slope or the constant to be able to compare them. So example number 2 says the equation y equals 2 7/75 x represents the rate in barrels per hour that oil is pumped from well A. So in the table, it is giving me the information from well A. Label it as well A. The graph represents the rate that is pumped from well B. Which well pumped oil at a faster rate? So I just need to get the constant or the slope from the table and the graph. It says use the equation y equals 2 7/75 x to make a table for well A's pumping rate in barrels per hour. Well, they've already filled in the table for us. They took the number of barrels, since that was a total. That's the y. Per hour, that's time. Time is independent. That's the x variable. On the table, it's always going to be x and then y, so have yours labeled. So since it was giving me the constant of 2 7/75, they filled in that, because that y divided by x would give me this number. If you divide 5.5 by 2, it's going to give you this answer. 8.25 divided by 3. The constant of this table is 2.75. Use the table to find the slope of the graph of wells A rate. So slope is the same thing as unit rate. So I'm doing y divided by x. The first y was 2.75 divided by 1 gives me 2.75 barrels per hour. If I wanted to write it as the slope, you would want it to be in a fraction. So I can type in that constant, 2.75, and hit math, enter, to get the slope of 11/4. So say m equals 11/4. And k equals, for constant, 2.75. So you'll write your slope as a fraction, your constant as a decimal. Step number 3, because we wanted to know which one is pumping oil faster. So I know how fast well A is. 3 says use the graph to find the slope of well B. Alright, so on a graph, you need to use rise over run to get the slope. This graph is crossing at 0, 0 is the first point. The next time that it crosses at an intersection, looks like it's right here. You need to know what the x and y axis is counting by. So it goes from 0 to 10, and it's broken up into 1, 2, 3, 4, 5 segments. So 10 divided by 5 is telling me that this is counting by 2's. The same thing is happening on the y axis. 2, 4, 6, 8. Now I need to count rise over run. So I'm going to start at the lower point and count the rise. It goes 2, 4, 6, 8, 10. Put that on the top of your fraction. For the run, I count by 2's. 2, 4. 10/4 will reduce to 5/2 because they both divide by 2. So the slope that we got was 5/2. I can change it to the constant whenever it's a proportional relationship, and this is proportional because it goes through the origin and it's linear, it's a straight line. So the constant would be 2.5. So it says compare the slopes. For well A, we had 2 7/75, or 11/4, but it's easier to compare the decimals. And for well B, we got the slope of 5/2, so I'm going to be changing it to a decimal to be able to compare them. 2 7/75 is greater than 2 50/100. Describe the relationship among the slope of the graph of well's A rate, the equation representing well A's rate, and the constant proportionality. The slope is the same thing as unit rate. And the constant for proportional relationships. The slope is the same thing as the unit rate and the constant. So to answer example number 2, we need to say that well A was the one that was faster. So circle well A.